Good morning. In this session, let us understand a problem on heat engines, cyclic heat engine, problems on cyclic heat engines. So here, let us read the problem. A cyclic heat engine operates between a source temperature of 800 degrees centigrade and a sink temperature of 30 degrees centigrade. What is the least rate of heat rejection per kilowatt net output of the engine? Okay, so here it's a cyclic heat engine. So before going to solve the problem, just we have to draw the block diagram of the heat engine first. So we know the block diagram of a cyclic heat engine. So it has a source, right? Top a box. So it's a source and it has a sink and the heat interactions. Okay, source means high temperature reservoir, isn't it? The high temperature reservoir. So sink means the low temperature reservoir. Then Q1, the symbol which is used for heat supply. Q1, okay, Q1 it's a heat supplied from the source, and Q2 is a symbol for heat rejection to the sink. The heat rejected to the sink, it is Q2. Then W, work done, the net work output from the heat engine. It's an output from the heat engine. The formula is Q1 minus Q2. So heat supply minus heat rejected gives the work done by the heat engine. So this is a basic block diagram of reversible heat engine. So here in the heat engine, let us understand the given data. Source temperature. So cyclic heat engine, source temperature. So it is 800 degrees centigrade. So here T1 is equal to 800 degrees centigrade. But here I converted degree Celsius into Kelvin. Okay. So for converting degree Celsius into Kelvin, what we have to do? We have to add by 273. So 800 plus 273 gives 1073 Kelvin. Then sink temperature, that is low temperature, 30 degrees centigrade. So 30, so degree centigrade. In order to convert it into Kelvin, we have to add it by 273. So 273 plus 30 gives 303 Kelvin. So source temperature 1073 Kelvin and the sink temperature is 303 Kelvin. So T1 and T2 we know, we just note. Then what is the least rate of heat rejection per kilowatt net output of the engine? So per kilowatt means per 1 kilowatt. For 1 kilowatt net output of the engine. So here what is the net output? W is equal to 1 kilowatt. So 1 kilowatt net output, we have to find the least heat rejection. Heat rejection means Q2. Heat rejection means Q2. Heat supply is Q1. So we have to find the least rate of heat rejection Q2. So least means they are indirectly giving, indirectly saying that it is a reversible heat engine, isn't it? Reversible heat engine means which gives least heat rejection, maximum efficiency. Okay, maximum, it will only the reversible engine gives the maximum efficiency and least heat rejection. So we can use the relations for reversible heat engine also. So what's the relation means? So we know already the efficiency of heat engine, right? Efficiency is equal to 1 minus T2 by 2 now. Actually for a heat engine, the efficiency formula is 1 minus Q2 by Q1. Okay, Q2. So for reversible heat engines, we can use the temperature relations directly. T2 by T1. So we can find this value easily because we know the value of T2 and T1. So T2 is 30 plus 273. T1 is 800 plus 273. We get the value of efficiency as 0.718. 0.718. So we find the reversible efficiency. So one more, we can use another relations for efficiency is work done by heat supplied. We already know, right? Efficiency formula is work done by heat supplied. So here what is the work done? So in the question itself they are giving 1 kilowatt work done. Then what is the heat supplied value? We have to find, right? Heat supplied Q1. So efficiency we know 0.718. We get the value of Q1 from here as 1.392 kilowatt. Then how to find the value of Q2? So we already know, right? W is equal to Q1 minus Q2. So we can use these relations. Q2 is equal to 1 minus W net. We get the value of Q2 as 0.392 kilowatt. So this is the least rate of heat rejection. Okay, so this is how we have to solve the problem of heat engines very easily. Okay, just what we have to do is first we have to draw the block diagram of the heat engine. So here representing the source at the top and sink at the bottom. Source means the high temperature, sink means the low temperature, then heat supply is Q1, heat rejected Q2, and work output of the engine. So once we draw the diagram means we can use the formulas of the heat engines. Very simple formulas. We know the reversible heat engine, the formula is efficiency. We can use these relations. So and another relations of efficiency, maximum efficiency is work done by heat supplied. By using these relations we can find the value of unknown. Okay, thank you students.